Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Hurricane Michael Used to Cover Up Tidal Event Due to Planet X Approach. Now, the YouTube channel In Truth by Grace has done a good job of reporting that Hurricane Michael was not even close to being a hurricane on October 8th and October 9th, 2018. The cloud pattern associated with the storm, as seen on radar, started curving into a vortex shape on October 8th, indicating that it was artificially formed. However, on October 9th, only half of the vortex had formed. In addition, the winds recorded by ships and buoys in the areas affected by the hurricane were too low for the storm to be categorized as a hurricane, as maximum sustained speeds were no greater than 60 miles per hour. At the time it was located near Cuba. A Category 1 hurricane has to have a minimum recorded sustained wind speed of 74 miles per hour. The same YouTube channel also showed that on October 9th, when the supposed eye of the storm was north of Cuba, the winds recorded by buoys in the area did not show that sustained wind speeds had reached a speed which would indicate that this storm was anywhere near to a Category 1 hurricane, much less a Category 2 or 3 as it was being reported. So here's a radar image of the storm, which has been named Michael. As you can see, it doesn't look like a hurricane at all. There is no eye, there is no vortex around an eye. There was, In Truth by Grace did report that some rotation had started in this direction, but there was nothing to suggest that a hurricane had formed at all, because what you'd expect is a complete vortex. This was not in place at all. Now, here's the table that shows you how hurricanes are categorized. A Category 1 hurricane must have a speed of at least 74 miles per hour, which is equivalent to 64 knots. A tropical storm must have a speed of 39 miles per hour, which is equivalent to 35 knots. And anything below that, below 38 miles per hour, it's a tropical depression. It's not a tropical storm at all. So this speed, a Category 1, as I said, has to be 74 miles per hour or 64 knots. And not only that, this is a screenshot from a NOAA web page where they state that the Saffir-Simpson hurricane wind scale, which is what's shown here, it's the scale here, wind scale is a 1 to 5 rating based on a hurricane's sustained wind speed, not gust, sustained wind speed. And they shows a bit of the same numbers here. Now, this is the buoy data from the region where the hurricane was supposed to be on October 8th. And as you can see, there's the wind speed and knots. This is the wind speed. This is the gusts. So we have to look at the wind speed. That's sustained wind speed. As you can see, it starts from the bottom here. That's 1454 there, 13. It goes up to 15 by 3 o'clock, 1500, 1600. The maximum seems to be 33. And this was recorded by a ship in the area, 33 knots. Now, 33 knots translates into 38 miles per hour. So let's look at our table. 38 miles per hour. Oh, that is below tropical storm. That means that this was not even a tropical storm. This was a tropical depression. And that was the maximum, only recorded once. The rest were all below that. As you can see, there's 27. Okay, so it looks like it rose around that time at about 3 o'clock, there's a buoy reporting a 27 knot speed, and then the boat recorded a 33. But by 4 o'clock, it had gone down to 12. So that's definitely not even a tropical storm. This is not even a tropical storm. This is a tropical depression. So what did NOAA report in their bulletin here? And this one is from Tuesday. No, this one is from, I think, Monday still. And they're reporting that this was, I think this was from Monday night, a tropical storm watch. In other words, they're saying this is a tropical storm. But the data shows this was not a tropical storm. It never reached tropical storm sustained wind speeds, according to the buoy data. Now they do talk about reconnaissance aircraft, which indicate a maximum sustained wind speeds have increased to 85 miles per hour. But that's the aircraft, which is up in the air. That's not the same as what we would expect at sea level, because only the winds at sea level would cause the damage. Only the winds at sea level would cause the storm surge, and we'll talk a lot more about that just now. So NOAA was reporting that Michael was a tropical storm and forecast to become a major hurricane. Sustained, the next tema is forecast to become a major hurricane by Tuesday night. By Tuesday night. So they were reporting this on October 8th. Tuesday night would have been October 9th. How is that possible? The buoy data show that it was only a tropical depression. How can the reconnaissance aircraft measure something that is not corroborated by the buoy data or the radar images? Obviously not. And what really matters is winds on the ground or on the surface. So we cannot really infer anything from the reconnaissance aircraft. And the buoy data clearly indicates that wind speed never went close to being what would be expected from a tropical storm on October 8th. And there was definitely no cloud vortex to indicate that any hurricane or any cyclonic storm had formed. There was no cyclonic rotation. So how can they forecast that this was going to become a major hurricane? Well, the only possible reason they can do that is because they were planning to manufacture the hurricane. In the case of Hurricane Florence, the first time that a Category 1 hurricane wind speed was measured was when the hurricane reached shore. So it seems that they only have the ability to generate such a storm close to land, possibly because that is where the radar, that is the next rad stations are, which they seem to use to energize and steer these storms. This means that these are not real hurricanes. These are artificially created storms, which only take shape when they are supposed to be very near to shore. The rest of the time, they are an imaginary fabrication by NASA and NOAA. And this is a screenshot from the video from In Truth by Grace from October 9th. As you can see, there is a half an eye there. There is no clear vortex yet. We're starting to see what seems to be some kind of rotational vortex, but it's not complete. This is not a hurricane. So this seems to be a forming artificial storm system with the potential for cyclonic circulation. A major hurricane was supposed to form by Tuesday night, October 9th. This is Tuesday night, October 9th, 9 p.m. We do not have a hurricane. But they said that a major hurricane, by major I would think it would be a Category 2 or 3. This is not what we see on radar here. And we can see here that this is the bulletin from Tuesday night, where NOAA categorically states that Michael is a Category 3 hurricane. And in fact, then they go on to talk about some of the buoy data, which shows that they use the buoy data to categorize hurricanes. And they talk about the 1 minute mean winds of 63 miles per hour. 63 miles per hour is way below 74 miles per hour. So this is not a category 1 at all. And yet you're talking about a category 3. Where did you get the 120 miles per hour? Let's see the data that shows that. Because the buoy data does not show that. They even talk about buoy data 42003. You would think that they would talk about the buoy that shows a wind speed of 120 miles per hour. But they don't do that because there is no such thing as a buoy showing that data. And in fact, they even went on and they actually show that they manipulated the data for this buoy, because they say it's a 1 minute mean, but yet the buoy data measurements are 10 minutes apart. So by a 1 minute mean, it means that what they did was they went through the day's buoy data for that buoy, 42003, and they looked for where there was a maximum sustained wind speed and a maximum wind gust speed, and they averaged the two, and they called that a 1 minute mean. In other words, they had to manipulate the data from one buoy and to make it seem as strong as possible, but it's not even strong enough. The wind gust speed is 72 miles per hour. This is what they state, and a wind gust of 72 miles per hour. This is how good the data that they have is. They had to manipulate that to make it seem greater than what it was, but they still only got to 63. That is way below 74 miles per hour. This is not a category 1 hurricane, and they are saying this is a category 3. And what I'll explain later has all to do with the fact that they want to say that the storm surge will be between 9 and 13 feet. This is what they are trying to justify. So a major hurricane was supposed to form by this time, Tuesday night, October 9th, but no hurricane appears on radar or from the buoy data. We are supposed to have a category 2 or 3 hurricane, a major hurricane, but we only have a tropical storm. That's what the data shows. NOAA categorically states that it is a category 3, but the data shows that they are clearly lying. And here's the data from October 9th, 2018. This is the buoy data. And this is from 9 p.m. onwards. You see, 2100 up to midnight. So that would be October 10th. And we can look at the sustained wind speeds here. And we start out with 46.6 and it goes down to 36.9. Now 46.6, and that's in knots. 46.6 knots is 53.6 miles per hour. But in order for it to be a category 1, it's got to be 64 knots or 74 miles per hour. So this is definitely not a category 1. This is strong enough to be a tropical storm, because a wind speed of at least 35 knots means that it's a tropical storm. So what we have on October 9th, on Tuesday night, is a tropical storm. We definitely do not have a category 1 hurricane, and we definitely do not have a category 3 hurricane, as NOAA said we had. Notice as well the temperatures that go along with it. This is air temperature, this is water temperature. And the water temperature with that maximum wind speed here of 46.6 was 82.2. And that's about the maximum water temperature that we get here. It was below that. It went down to 82 here. By 10 o'clock it was below 82. And why is that important? Because the water temperature has to be at least 82 degrees in order for a tropical cyclone to form or be sustained. This is exactly what it says in this NASA webpage. Sea surface temperatures must be 82 degrees Fahrenheit or warmer for tropical cyclone formation and sustenance. In other words, if it drops below 82 degrees, the hurricane, the cyclonic storm, cannot be sustained. So what we have is water temperatures dropping below what would sustain this tropical storm, because it's nothing more. So, and yet, on October 10th, the 10 a.m. bulletin states categorically that the core of extremely dangerous Hurricane Michael closing in on the coast of Florida Panhandle. So, what are they saying? Are they saying that a tropical storm is an extremely dangerous hurricane? It's not even a hurricane. It could not have been sustained all night because the temperatures dropped at least until sunrise, and then the temperature increases slowly. So they are clearly lying. So how could NOAA report that an extremely dangerous hurricane was approaching the Florida coast when at midnight, October 10th, the storm could not be classified as anything but a tropical storm? And in addition, the water temperature, at least until midnight, was too low to sustain the storm. The water temperature would be likely to drop further after midnight and until sunrise, which should make the sustainability of the storm even worse. But why would they manufacture a storm and lie about its strength in such a blatant manner? It seems to be all about the storm surge. They know a tidal surge is going to occur. They cannot stop it, but they can try and justify it with a fake, artificially produced hurricane. And here, so this is from October 10th. This is still from the 10 a.m. Bulletin. And as you can see, they are reporting sustained wind speeds of 54 miles per hour and a wind gust of 61 miles per hour. This is not a Category 1 hurricane. This is impossible. How can it be an extremely dangerous hurricane when the sustained wind speeds are only 54? That's of a tropical storm, that is all. But they forecast a maximum storm surge of 9 to 14 feet. And this is the reason why they want to say it's a Category 3 or a Category 4. They want to justify this, the storm surge. Notice that with Hurricane Florence, the storm surge was initially forecast to reach a maximum of 10 feet at Wilmington Beach, when NOAA was stating that it would impact the coast as a Category 3 hurricane. The hurricane turned out to barely be a Category 1, and that only once it reached shore. And yet the storm surge prediction was never revised as the category of the hurricane was. Not only that, a storm surge even higher than that was confirmed at New Bern. It reached 7 to 11 feet. How is this possible? They simply needed to manufacture the hurricane in order to justify the tidal surge, which they knew was going to occur. And I did not make a mistake by saying it's a tidal surge. It is not a storm surge. And this is a screenshot, the Weather Channel, stating that a storm surge of 7 to 11 feet had been verified at New Bern on September 14, 2018, the day that Hurricane Florence reached shore. And this is from October 9th. And you can see on October 9th, they were forecasting a maximum storm surge of 9 to 13 feet. So just slightly lower. And this was when they had falsely classified Michael as a Category 3 hurricane. And it was not even a Category 1. Thus, it seems that these manufactured storms are a cover-up for tidal surges. These are not storm surges. These are tidal surges, which they are trying to justify with artificial hurricanes. These hurricanes are so artificial that at times they only exist in the imagination of NOAA and NASA. Tides are produced by outside gravitational influences on the planet. Normal tides are caused by the gravitational attraction of the moon. These abnormal tides, which NASA and NOAA are trying to hide with manufactured storms, are caused by objects, stellar cores belonging to the Planet X system, which are approaching the Earth. This started in 2017 with the unprecedented water recession events and tidal events which started occurring around the world. And this is the one in Uruguay, this is the one in Brazil from August. This is the tidal surge that occurred in South Africa, Durban, South Africa, in March of 2017. This is what they are trying to cover up. This is what would occur on the Florida coast, and they don't want people to figure out that there are objects in outer space that are causing this. So they manufacture these hurricanes. They are using artificial cloud seeding to generate a lot of rain and causing the air mass saturated with rain and with metallic cloud nucleation centers inside it from chemtrails to rotate by hitting them with radar, i.e. intense radio waves in a certain pattern. The excessive rain over land is used to cover up the fact that the gravitational wave associated with the stellar core approaching the surface of the Earth at this region would also affect lake and river levels, in addition to the sea level. This level is set by the gravity over this region, and these objects exert strong differential gravitational, in other words, tidal forces, because they are most likely larger and stronger than the ones that had been approaching Earth before. This means that all this damage to property and life, which they are artificially creating, is only because they are desperate to hide what is going on in the solar system from the Earth's population. In conclusion, Hurricane Michael is an artificial hurricane produced to cover up the approach to Earth of Planet X objects, more gravitationally powerful than the ones that have been approaching Earth before 2017. These objects are closely approaching the surface of the Earth and exerting strong gravitational forces on the Earth as a result. And these are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching. Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Hurricane Michael, Tidal Event Due to Object Approaching from Space. Now, in Article 370 entitled Hurricane Michael, used to cover up tidal event due to Planet X approach, I detailed how when Hurricane Michael was being reported as a tropical storm close to Cuba on October 8, 2018, it was no more than a tropical depression or simply a rainstorm, which seemed to have been produced in the area through most likely cloud seeding or chemtrails. On October 9th, the storm was reported to be a Category 3 hurricane, but sustained wind speeds from buoy data show that it was only a tropical storm, as it had not reached Category 1 wind speeds. Now I'm going to show that the buoy data continue to show that the wind speeds associated with this hurricane close to the region where it made landfall never reached Category 1 strength, and that therefore the hurricane did not approach from the ocean but from above. There were no winds to cause a storm surge, so the inundation could only have been caused by a tidal event or gravitational force exerted by an object approaching from space. And here's an image from CNN indicating how the hurricane made landfall at Panama City. And you can see how wide they show that it is. So as the hurricane, if it approached from the sea, would have affected all these buoys along here. So we're going to look at the buoy data. And so this is CNN reporting from Panama City at 1 p.m. local time, that's 1800 UTC, that the hurricane had just made landfall. And it was reported to be a Category 4 near Category 5. And here they are reporting that a storm surge had already reached 8 feet at Apalachicola at 1:04, so at 18:04 UTC. And this is a photograph from that region, Apalachicola, showing that it was inundated, as you can see. Now we're going to look at the data from these 3 buoys. I'm going to call this one Panama City Buoy 1, this one Panama City Buoy 2, and then I'm going to look at this one, the Apalachicola buoy here. And these buoys, as you can see, this one, Panama City 1, is in between these 2. So we're going to look at that. Now, starting with Panama City Buoy 1, we can see, well, they do not show wind speed here. It wasn't recording anything at the time. But it does show us what all the columns are for. So we have the first 3 is for the date, the next 2 is for the time. This is wind direction in degrees. This is wind speed in meters per second. This is gusts in meters per second. We're going to focus on wind speed and on air pressure. Pressure in hectopascals. Standard air pressure is 1000 hectopascals. So anything below that is a low pressure and would indicate that a storm is over the region. A low pressure and there's a storm. This table shows the classification for hurricanes, and we need the meter per second reading because our data is in meters per second for wind speed. And we can see that a Category 1 hurricane has to have a wind speed of 33 meters per second, and a tropical storm has to have a wind speed of 18 meters per second. So looking at Panama City Buoy 1 data, well, first of all, we can see here that the pressure dropped below 1000 at 11:54. And that's when we could say that there was possibly something approaching. However, the wind speeds do not indicate any hurricane approaching because the wind speeds are way below 33 meters per second, and they do stay that slow until 1512, and that's less than 3 hours before the hurricane made landfall. So the hurricane, especially a hurricane Category 4 hurricane, should have been impacting this area way before. So we should have seen increased wind speeds here, and we do not see them. Now here we see that the minimum air pressure was reached at 1748. There it is, 937.5. It was higher. After that, it was higher before that. So this was the minimum air pressure, and this was 12 minutes before landfall. And this buoy is very close to where the hurricane made landfall. So we should have had, it doesn't show speeds, but it does show that the maximum air pressure was, the minimum air pressure was minimum just before that time. So that's probably correct. It did make a landfall just before 1800 or around that time. Now here we see, so that didn't show us any wind speeds, but we see the wind speeds. It did show wind speeds until 1718, and the wind speed then was 31.9, and this was way below what we would expect for a hurricane. I mean, it's not even a Category 1. This is 31.9. Category 1 has to be 33. This was a Category 4. So the wind speed should be much higher than that. You can see that the pressure was low, but the wind speed was not. And we can see here what occurred after that. it was at 23:30 that the air pressure went back to normal. So this would suggest that there was a storm over the area until 23:30 on October 10th. That's what buoy 1 shows. Now buoy 2 shows air pressure dropping at about the same time, about 11:54. You can see here. But the speeds again are very low. Maximum wind speeds 12.9 meters per second, and we cannot go to gusts. We have to have sustained wind speeds to categorize the hurricane. So only 12.9. Now the minimum pressure was reached at 17:48, again about the time that the hurricane was making landfall. But the speed at that time was 21.6, 23.7, slightly higher. It reached 27.3 at 1906, but then it went down again. So this seems to be the maximum wind speed reached. This is way below Category 1 hurricane wind speed. So we do not see a Category 1 hurricane impacting the area where this buoy is at all. Not moving through it, not impacting it. We do see that something did land from these very low pressures, but we do not see wind speeds. And remember, storm surge can only be caused by wind speed, not by low pressure. Not a storm surge, something else called a tidal surge may be indicated by pressure. I'll talk about that just now. So the lowest pressure here was 972.6. This was not as low as it was reached for Panama City Buoy 1, which was 937.5. And this indicates that this buoy, Panama City Buoy 1, was closer to the center of the storm, and that agrees with the hurricane making landfall at Panama City, because this buoy is closest to Panama City. The other one is very close, but slightly further out. But the wind speed does not indicate anything close to a Category 1 hurricane. This was supposed to be a Category 4. Now let's look at the Apalachicola buoy data. This seems to be where the strongest inundation seems to have occurred. This seemed to have been closer to the center of the storm than that one. This is Panama City Buoy 1. This is Panama City Buoy 2. If we look at the data here, we see that again the pressure dropped to below standard at about 11:54, the same as for the other two. But the maximum speed, wind speed we see here was reached here, 22.1 at 14:48, again at 1500, 22.1, way below Category 1 wind speed. And here we see that the pressure went back to standard at 2306, about the same as for the other two. The minimum pressure was 985.3. It was reached at 1748, again very close to landfall time. The maximum wind speed was reached here, 27.3, just before minimum air pressure was reached. This was the same as at Panama City Buoy 2, exactly the same wind speed. But yet we're supposed to have greater inundation here, but the wind speed does not even reach Category 1. It never reaches Category 1 strength. So we had a hurricane come down with a huge diameter, but the wind speed that it created did not reach this buoy, Apalachicola buoy. So how can we make sense of this data? These buoys never show that a hurricane had passed overhead, as the recorded wind speeds were always below hurricane force. In addition, the air pressure started dropping at around 11:54 and went back to standard air pressure at around 23:06 for Panama City Buoy 1 and Apalachicola, but a little later for Panama City Buoy 2, but about the same, just a few minutes later, like 24 minutes later. So the pressure dropped for about 12 hours, with the landfall time of 1800 being around the middle of that time interval. But wind speeds never reached hurricane force and were lower in Apalachicola, where the inundation seemed to be greatest. Well, they were at least the same as Panama City Buoy 2 wind speeds. And there was no evidence that a hurricane passed through the region of the buoys. How can a hurricane make a landfall just north of the buoys without it passing the buoys? How can the hurricane have such a huge diameter if it made landfall in Panama City without high winds being recorded by the buoys? This suggests that the hurricane did not come from the ocean. It came from above. It landed in the area, and it must have had a much smaller diameter than was being reported. The tidal surge had a much higher diameter than the associated storm. That's what it shows. The minimum pressure was recorded at Panama City Buoy 1, so this must have been closer to the center of the storm, and the others were closer to the edge. This is, as you can see, source NOAA, and NOAA explaining how storm surge occurs. So NOAA shows that an approaching hurricane, wind circulation pushes water downwards, but that close to land it cannot be pushed down any further, and so surges inland. So there we are. So we need wind speeds from the hurricane to cause this water to be pushed down and therefore to push the water onto land. So we need wind speeds. We do not have wind speed. So how was a storm surge produced? We need wind circulation from the hurricane in order for the storm surge to occur. And we did not see that in the data. Air pressure, we did see air pressure difference, but air pressure cannot push water downwards. If anything, low air pressure should allow water to rise up because it is pushed down with less force. This means that we had what was reported to be at least a storm surge with no hurricane force winds offshore to push it onto land. In other words, there was nothing to cause a storm surge. So this had to be a tidal event. The data shows very low pressures, and the highest wind speeds are reached around the time that the pressure is lowest, even though they are too low to be hurricane force, and much lower than that than what was reached inland. The reported wind speeds on land were 155 miles per hour, which is 96 meters per second. But these winds were never recorded offshore, which means that a hurricane touched down over land. It touched down as a tornado does from above. The edges of the gravitational field then affected the ocean, and that was what was measured by the buoys. The water that surged inland was due to a tidal surge created by a gravitational anomaly in the area centered on a point on land. A normal tide on Earth is created by the moon. The moon is an external object as it is outside of the Earth's atmosphere. So a tidal surge of this magnitude would have to be created by an object approaching Earth from outside the Earth's atmosphere. Its gravitational field would create a low pressure and a corresponding tidal bulge somewhere under the object. The gravitational force should also give rise to circulating air in the form of an air vortex. This was the hurricane that touched down. This was why wind speeds of 96 meters per second were recorded. But notice, as shown here, where the wind speeds are maximum is a much smaller area than the diameter of the tidal surge. The tidal surge, you can see the tidal bulges here, that causes a ring around the circular region, and that ring has a much wider diameter than the storm that accompanies this object, which creates this tidal event. So this came over land, and one side of the tidal of the gravitational field caused a tidal bulge, which impacted the land. So probably part of it was on the land, part of it on the ocean. That caused the tide to surge upwards, and it caused the land to be invaded by the ocean. It was a tidal surge. Now, this is the type of gravitational wave created by an object approaching from outer space, a stellar core. These are the objects that are invading our solar system. And notice it's a wave. It's a stationary gravitational wave with highs and lows. Where there are lows, you will get an ocean recession event. Where there are highs, you get a tidal surge. Gravity seems, therefore, to be a stationary wave, and I've written about this, and if you want more details, you may look at Article 349 entitled Planet X, Gravitation and Electric Effects on the Planets. This is why all gravitational vortices have central hollows. We have a central hollow here. The eye of the storm is always a hollow space. And this is why, because the gravitational wave always has a hollow at the center, a minimum at the center. So, and regions of low, decreased ocean level, you see, that's where the lows occur. That's where the gravitational field over the surface of the ocean is increased, where the gravitational field of the object is actually pushing the water downwards. It is helping the Earth's gravitational force. So it's pushing the sea level downwards. It causes an ocean recession. If a plane flies over it, it will be pushed downwards towards the surface of the ocean or the surface of the ground if this wave happened to be over ground. Now, a gravitational wave, this is a gravitational vortex created in a water container where there's a hole at the bottom, and this gravitational vortex is caused by the Earth's gravitational field pulling down on the water. The gravitational vortex always has a hollow in the center because the gravitational field, gravity always produces a gravitational field which is hollow at the center. And the areas where we get troughs in this wave are where we get recession events, and these recession events started occurring in 2017. These are due to tidal forces. Tidal forces can only be caused by objects from outer space. In this case, there were no storms that were reported to be associated with these events. Probably because they have such small diameters, whilst the ocean recession event is further out from the center as well. There it is, and so there was no storm around when this occurred. So in conclusion, the hurricane which affected the region around Panama City on October 10, 2018, and which led to a huge amount of inundation from the ocean, could not have been caused by a hurricane which formed out to sea and blew water inland, as the buoy data clearly shows. The inundation which occurred had to be caused by a local gravitational anomaly, which only an object closely approaching Earth from space can cause. And these are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching. Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled The Connection Between Hurricanes, Waterspouts, and Comets. Now, figure 1 below shows a gravitational vortex produced in water when a small hole is made at the bottom of the container. The vortex forms due to the Earth's gravitational field pulling on the water. The water right above the hole falls in, causing water above it to move downwards as well. They move as if they are attracted to the hole, and thus the hole acts as a source of gravitational field, attracting matter toward it. But a source of gravitational field generates a stationary gravitational wave, which has a central hollow, so that the water spirals around the hollow. The direction in which the water spirals is determined by the local magnetic field. A gravitational field never exists by itself. There are always electric and magnetic effects, which always coexist with the gravitational field, because the same charged particles, mainly protons and electrons, give rise to all three fields. So here's these gravitational vortices, or water vortices, and these are created by a hole at the bottom of a container, so that the water starts moving towards the hole. It's attracted towards the hole, so the hole is acting like a source of gravitational field. But the vortex always has a hole in the middle, a hollow space in the middle, and that is due to the fact that the gravitational field produces or has a gravitational wave associated with it that has a central minimum. Now, figure 2 below shows a water spout in the Earth's atmosphere. There it is. A water spout is basically the same as a tornado, but it moves over water, whilst a tornado moves over land. A hurricane is similar to both, as it too is a vortex, but a hurricane is much larger, and the vortex usually only affects the atmosphere, and is thus not strong enough at surface level to draw water or solid objects up into the upper atmosphere. So here's a water spout, and it's a gravitational vortex. It's actually the same as a vortex in water, except it is a water vortex, but it acts in the opposite direction. Water can be seen spiraling upwards around a central space. So you can actually see the water here forming the spiral as it moves upwards into that cloud. Water is forced upwards by a gravitational force which pulls it upwards. In other words, the gravitational force which is pulling this water upwards is the source has to be up here somewhere. It's not caused by the Earth. It's caused by something else. Now, water spout is a water vortex, but in reverse to what we see in figure 1. Water is being drawn from the surface of a big container, the ocean, up into the air. Because the water is spiraling upwards, the source of the gravitational field, which is creating the vortex, must be at the top of the spout. What is the source of gravitational field? It most certainly is not the Earth. A natural gravitational field can only be created by the existence of a massive object. Therefore, there must be a massive object at the top of the spout. The object must be surrounded by cloud. So it is not visible, but it must be there nevertheless. What kind of object is this? It is a Planet X object or stellar core, one of the energy-depleted objects which invade the solar system, coming in as comets. And you may look at Article 367 entitled Planet X coming in as comets and affecting the Earth. They draw energy from the sun and are often seen in the sun's corona, which is the sun's atmosphere. Since stars and planets are not very different, if these objects go into the sun's atmosphere, they will go into the Earth's atmosphere as well. And here you see one of these objects. You can see the vortex, the gravitational vortex under it, which has caused it to connect to the sun. And this is why these objects can hover in a stationary position with respect to the sun. Once this connection, this gravitational vortex forms between the object and the sun. So since tornadoes are the same type of gravitational vortices as water spouts, but over land, have been observed in the Earth's atmosphere for a very long time, these objects must have been coming into the Earth's atmosphere for a very long time, at least since 1643. And for more details, you may look at Article 361 entitled Planet X producing gravitational vortices in the Earth's atmosphere since 1643. These objects are most likely very small, possibly the size of small moon cores. However, the incidence of tornadoes and water spouts has greatly increased over the last 10 to 30 years, suggesting that more and more of these objects are reaching the Earth and entering our atmosphere. The reason why the stellar cores do not collide with the Earth is that they are star, planetary, or moon cores. Stellar cores generate positively charged surfaces. Thus, this surface will be repulsed by the Earth's core, which also generates a positively charged surface. The objects come in as comets, seem to spiral in toward the host body, which can be the Sun or the Earth, reach a minimum position at which time they may remain stationary with respect to the host. And you may look at Article 373 entitled Planet X Orbits for more details. But this only occurs if the gravitational attraction is strong enough for a vortex connection to form. So here we see two objects. This one represents the Earth. It has a positively charged core. It has a negatively charged outer layer. This could be a stellar core or a comet once it has absorbed some energy from the Sun and it has absorbed some corona from the Sun, then it may have a small negatively charged layer. Otherwise, these negative charges are absorbed because the object is low in energy. But in this case, I have drawn it as an object that has absorbed some energy since it has come into the solar system. And now there are two forces acting on this object. There's the gravitational force, which is attractive, pulls it towards the Earth, and there's the electrostatic force, which is repulsive, which causes it to move away from the Earth. When these objects reach minimum distance, these two forces are in balance. And notice they are, the outer layers, the atmospheric layers, are in contact here. They are not repulsed until these make a connection because the negative outer layer shields the positive interior. Now, only at the critical minimum distance of altitude will the object be able to draw materials from the surface, be it ocean or land. The object has to have enough gravitational energy to be able to reach that minimum critical distance. Otherwise, it's too far up and the vortex that it forms is not long enough to reach the surface of the Earth and does not form a full connection with the surface of the Earth. The object then will not hold a stationary position. Now, hurricanes are most likely produced by larger objects which have not yet gained enough gravitational energy to be able to spiral in as close to the surface as the smaller objects. And I talk about spiraling because as they approach the Earth or the Sun, they will go into an elliptical orbit and spiral around. That is, they will come to a perihelion position every couple of hours, but that perihelion position will decrease. They spiral in. And this is shown in Article 343. Now, so hurricanes spiral in, and they may not reach the lowest critical distance, the minimum critical distance, because they may not have enough energy for that gravitational force to be strong enough to be able to draw it in close enough to the planet, because the electrostatic force will always act against it. But as they gain gravitational energy through the atmospheric vortices which they create, they will be able to come in close each time they approach the host object until they manage to reach the minimum critical distance or altitude when a vortex forms between them and the Earth's oceans or surface. And this is illustrated here. Our stellar core, as it approaches a planet, if it's a very large object, it may produce a stationary gravitational wave ring on the surface of the object. So if it's ocean, it will be seen as a wave, a tidal wave on the ocean. As the object approaches, the tidal wave increases in height. It always has a central minimum It always has a central hollow. And then once the object reaches the critical minimum distance, a gravitational wave vortex forms. It will also have a hollow in the center, but this vortex makes a direct connection between the two objects, and the stellar core will be able to draw material from the Earth through it. So in the Earth's atmosphere, we have a water spout or a tornado. Here I've drawn a water spout which has reached the critical minimum distance, so it's able to draw water from the ocean, and it draws that water, and then it becomes part of the object's atmosphere. Whilst a hurricane producing stellar core produces a larger vortex. We do know that hurricanes produce larger vortices, but these are only in the atmosphere. It does not go far enough because the object is not close enough to the surface, has not reached its critical minimum distance for its gravitational force to pull on the surface of the Earth strongly enough to produce that vortex connection. So it only makes a vortex connection with the atmosphere, can only draw atmosphere. It does create winds, cyclonic winds below the vortex, and these are what we usually call hurricane force winds. But it is not able to draw water or dust into the upper atmosphere, which then becomes part of its atmosphere. This means that the objects that create tornadoes and waterspouts have enough gravitational energy to reach the minimum critical altitude, but hurricane-producing stellar cores do not form water vortices, indicating that they do not have enough energy to reach the minimum critical distance to the Earth's surface. The vortices which they form in the atmosphere do not reach all the way to the surface, and so only draw atmosphere. As air is drawn upwards by the vortex, air below also circulates at high speed, and thus high winds are generated below the object, all the way down to the surface. But the cyclonic circulation is not strong enough to draw water materials into the upper atmosphere. So in conclusion, storm vortices, waterspouts, tornadoes, and hurricanes in the Earth's atmosphere are gravitational vortices created by massive objects, stellar cores, which are members of the Planet X system of dead stars and which enter the solar system as comets. A gravitational vortex connection with the surface is demonstrated when water or surface dust is drawn up into the vortex. A hurricane-producing object is larger and thus produces a larger vortex, but does not reach minimum critical altitude, and thus the vortex it creates does not reach the surface. And even though cyclonic air circulation is produced under the object at the surface, it cannot draw water or other dense surface materials upwards. Those are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching. Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Hurricane Michael Points to Coming Cataclysmic Tidal Flooding. Now, in Article 374, entitled The Connection Between Hurricanes, Waterspouts, and Comets, I showed how Planet X system stellar cores, or energy-depleted objects which come toward the Sun as comets, create gravitational vortices inside the Earth's atmosphere. I also detailed the difference between the vortices which we call tornadoes and waterspouts and those which we call hurricanes. The hurricane-producing stellar cores are much larger than those that produce the tornadoes and waterspouts, as the vortex is much larger, but they do not come as close to the Earth's surface, so their vortices do not reach down to the surface, so that they are only able to draw atmosphere and not surface material like water from the ocean or dust from the ground. However, if the hurricane-producing stellar cores had enough gravitational energy to reach minimum critical altitude, they would most likely produce enormous vortices which would be able to draw huge amounts of ocean water in a short amount of time. And this is what's illustrated here. And this is, well, it could be a larger Planet X object or a comet. And it is able to form this huge vortex because it has reached the minimum critical distance, but it also still has a lot of gravitational energy in its particles. So it exerts a strong gravitational force. So when it comes close enough to the Earth, it would produce a huge vortex because it's a huge object, and it would quickly draw most of the Earth's oceans, and they would then become part of its atmosphere. The reason why the stellar cores we have encountered thus far do not lift large amounts of ocean at a time is because they are dead or energy depleted. They are no longer able to generate gravitational energy in their cores and so absorb energy from other objects that do, like the Sun and the Earth. But the process seems to be inadequate, probably because it cannot fully replace a living core and because the objects absorb energy from each other. So whatever is gained is quickly absorbed by the energy depleted core, and then it is shared between all neighboring objects. However, since the Sun is now extremely weak, it is likely that more of these larger stellar cores will be attracted to the Earth as a source of gravitational energy, and the Earth will be increasingly affected by larger and larger gravitational vortices generated by these objects. The hurricanes which seem to now be affecting the Earth, such as Hurricane Michael, seem to be stronger than those which have affected the Earth in the past. And you may look at Article 371 entitled Hurricane Michael, Tidal Event Due to Object Approaching from Space. Hurricane Michael seemed to produce a very strong or much stronger or very high wind speeds, but much narrower vortex with a wide gravitational wave forming over the ocean. A gravitational wave creates regions of higher and lower than normal sea level. And you may look at Article 349 entitled Planet X, Gravitational and Electric Effects on the Planets. And here we see a cross-section of what that wave looks like. So here's the object producing the gravitational wave. It would have a spherical gravitational wave around centered on itself. But as the wave dips down into the surface of the ocean, it would create these bulges, these tidal bulges, which are actually rings. This is a cross-section. If we were to look at it from above, we would see something like this. It would be a ring around a central hollow space. That's what we see here. That's the central minimum that the gravitational wave always has. But it's a stationary wave, so it will remain in this position unless the object moves. So it will only move across the ocean because the object moves across the ocean. The gravitational wave is a stationary wave. Now, a larger object at a greater distance will produce a wave with a larger radius. So a very large stellar core approaching the Earth would produce this type of tidal bulge. This would be the gravitational wave, and it's a ring all the way around the Earth. As the object approaches the Earth, the height of the tidal bulge increases, but the radius decreases until the object reaches the minimum critical distance, at which time this becomes a vortex. So a connection is made between the Earth and the object. There will still be a hollow in the center, and the object will now be drawing material from the Earth, which will become part of its surface or its atmosphere. However, the gravitational waves produced by these objects started occurring in 2017, as there were many water recession events as well as high tide events where the ocean invaded the land only to recede sometime later, indicating that these were tidal events. The normal ocean tides on Earth are produced by the moon. Thus, tidal events can only be produced by objects external to Earth, i.e. other celestial objects or objects approaching from space. And here you see two of these events which occurred in 2017. This was in Uruguay, this was in Brazil, and these are ocean recession events. And ocean recession events are produced at the same time as the tidal bulges, because you always get regions where the gravitational field reverses and where it causes a lower than normal sea level. This is the equilibrium position. In these regions, the center and outside this the first maximum of the wave, you get a minimum, and that causes the sea level to be lower than normal in the region where this a region that this would be over, and that would produce ocean recession. And this is what we see here. And we also had tidal waves come in, and these were not associated with a storm. So some of these events occurred without any storm being nearby, suggesting that the tidal effects and the storm effects are not connected and thus produced by different objects. Now, in this case, this was the Durban coastline in South Africa in March of 2017, where a tidal wave engulfed the land. Oh, it came in much further than the tide ever comes. And it was reported at the time that the hurricane was off the coast of Madagascar. But Madagascar is way too far for that hurricane to be associated to this tidal event. So there didn't seem to be any storm system associated with this tidal event. The storm effect seemed to thus be created by smaller objects coming close to the Earth, and the tidal effect seemed to be due to much larger objects coming close enough to the Earth for their gravitational fields to produce gravitational waves on the surface of the ocean without their approach being close enough to produce a gravitational vortex. So this is illustrated here. The event which became known as Hurricane Michael had both. It had the tidal effects and it had a strong wind vortex which did not seem to have quite the same diameter. It was a much shorter diameter than the tidal event. So what we would then have with Hurricane Michael was a very large object producing the tidal event, and smaller objects producing the air vortices or the hurricane. The actual hurricane had a very small diameter, so it was produced by a smaller object coming closer to the surface of the Earth, and thus producing a close to a gravitational vortex. The hurricane vortex does not actually touch down at the surface, so it's not able to draw material from the surface like a water spout or a tornado can. And you see a water spout here. It's a small object. It comes down to quite a low altitude and is able to form a vortex connection with the surface of the Earth, whilst a hurricane is not quite able to do that, but it does produce a larger vortex, so it must be a larger object. This tidal wave produced, and which was associated with it, must have been produced by a much larger object at a higher altitude. And since there was pink light that was seen in the sky, I have made this object pink. And so the pink actually comes from the energy absorption process, which leads to heating and ionization. which then results in light emission. So that's why these objects emit very bright colors. And you may look at Article 338 entitled The Planet X Effect, Heating and Ionization in Contact Regions. This suggests that larger objects with stronger gravitational fields are reaching the Earth. These objects are having stronger gravitational effects on the Earth. And judging by the frequency with which these strong hurricanes, accompanied by what is termed storm surge, which is actually tidal surge due to the gravitational influence of these objects, more and more of these systems containing large objects are reaching Earth. And you may look at Article 371 entitled Hurricane Michael, tidal event due to object approaching from space for more details. Now, as these objects gain energy, they will come closer to the surface, which will increase the height of the tidal waves until eventually huge vortices will start forming. But why is this happening? Most likely it is happening because of the sun's weakness. And you may look at Article 371 entitled The Sun is No Longer Shining, Satellite Images, where I detail why the sun is weaker, how we can know that it is weaker and is most likely not shining at all anymore, not emitting light. As the sun weakens, the objects will be more attracted to the planets as sources of gravitational energy. So, in conclusion, Hurricane Michael was a type of hurricane which incorporated storm vortices as well as gravity or tidal waves. The two effects are produced by differently sized stellar cores at different altitudes and must therefore be produced when more than one object or a system closely approaches the Earth. The increased occurrences of these types of events, which started in 2017, suggest that larger stellar cores capable of producing cataclysmic flooding are now reaching the Earth. And these are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.